is Team Charlotte presentation for GE Power Services Group Project. GE Power Services utilizes an online portal called Field Service Portal, or FSP, to capture turbine outages and manage other service-related opportunities. The data is entered into the FSP by General Electric service managers and is used to forecast potential future outages as well as track past outages. Due to the fact that multiple service managers can report the same outage on the same turbine, the data is often duplicated within the FSP. When attempting to forecast potential future outages, the GE Power Services team needs to spend unnecessary time and effort weeding out duplicate records for every legitimate outage that occurs per turbine serial number. In order to make the forecasting process more efficient and effective, the data being captured in the FSP needs to be reduced in a systematic manner in order to quickly identify the pertinent outage data. To reduce the data, we were given these 5 rules. We are only concerned with the 5 outage types: major, minor, MI, HGP, and CI. These primary outage types will never occur within plus or minus 30 days of each other. Therefore, we want to choose one outage from any that fall within plus or minus 30 days of each other. If we find more than one of the primary outage types or serial number within plus or minus 30 days, we want to keep the ones with an outage status according to a hierarchy provided. If there is still more than one outage with those matching criteria, we want to select the first one with an actual start date. If there is no actual start date, then we will use the one with the greatest event ID. We needed to make the problem simpler, so we developed a process map. We then used the process map to develop an algorithm. The algorithm assumed that the data is maintained in a relational database that will be leveraged programmatically in order to establish a repeatable process, and the actual implementation would include a mixture of coding methods. In order to systematically filter the FSP data, an algorithm was developed that follows the general rules of operation provided by the GE Power Services team. There were a number of attributes related to the data that could be used to narrow the results sets to the legitimate outages for each turbine serial number, including focusing first on 5 specific outages within the data. By filtering out the irrelevant outage types, the data rows reduced by 11.3%. After narrowing focus based on outage type, the algorithm identifies any serial numbers with multiple outages reported within the FSP. Once duplicated serial numbers are identified, the algorithm compares the planned start date for a set of duplicated serial numbers and identifies any records within the set that are outside of the 30-day interval window. The records that are outside of the 30-day window are added to the results set, and the records within the 30-day window remain in the process table. To further narrow the results after identifying duplicate serial numbers with outages within 30 days of each other, the records are sorted by the outage status reported within the FSP data. The algorithm first checks to see if multiple outage statuses exist per set of duplicated serial numbers. If a single status exists for all outages, the outage data for that serial number set will remain in process. If multiple statuses exist for all outages within a serial number set, the algorithm will sort the results from most important to least important and insert the most important outage into the result set and remove the other records from the duplicate list of outages. If an outage has a single outage status within a set of serial numbers, the algorithm will check the data to set to determine if the actual start date is populated. If so, the record with a not null actual start date will be added to the result set and the others removed from the duplicate list of outages. If the actual start date within duplicated set of serial numbers is null on every record in the set, the algorithm will order the results by event ID. The record within the set of serial numbers that has the greatest event ID will be inserted into the result set. After applying the algorithm based on the rule set provided, the data set sample provided was reduced by 17% and yielded the expected output at a 95% confidence level. As the information will be more readily available, the forecasting team will be able to complete more timely research and decision making on future outages or service opportunities. In conclusion, the algorithm developed will use a set of rules defined by the GE Power Services team to systematically create a result set that only contains legitimate turbine outages. By migrating these defined rules into a systematic program, it will not only completely eliminate the manual filtering and data massaging that the team currently undertakes, but it will also reduce the possibility of human error when identifying the most accurate result set.